Hey there, Math 8. We are moving on to section 5 of chapter 4. Right? Section 5, chapter 4. We're going to be going over our next exponent rule. We started this chapter by going over what you do when you have terms multiplied together, like 2x to the third times 3x to the fifth, right? What happens to the exponents when you're multiplying terms? You add them, right? And then we did a section where you have a power to a power, and what happens to the exponents when you have a power raised to another power? You multiply them, right? So today we are going to look at exponents when you are dividing. And you're going to want to think of a dividing problem as a fraction, because that's what a fraction is. It's something divided by something. All right, so here we go. One way. I say one way because there's different ways to do this, but I think this is the best for us. One way to simplify exponents in a division problem, notice a division problem is a fraction, is to use your knowledge of exponents to write out the problem in expanded form, kind of expanded form, but not exactly. Then cancel out the common factors. Oh, we're going to learn some good math here. All right, so you reduce the coefficient, you can see, and you multiply the rest back together. Let me show you what I mean. So I have this fraction, 4 over 6, and I think most of you know what this fraction reduces to. It reduces to 2/3. But my question is, why does it reduce to 2/3? And I want to show you. It reduces to 2/3 because 4 is actually equal to 2 times 2. And 6 is actually equal to 2 times 3. Now, I talked about this in one of the classes yesterday, but when you are multiplying things together, those are called factors. Things that are being multiplied together are called factors. And when you have a division problem or a fraction, you are allowed to cancel out common factors on the top and bottom. And you can see in this problem, there is a common factor of 2. I can cancel out the 2, and that leaves me with 2/3, which is the answer, right? All we did is cancel out the common factor. So I'm going to write that down actually. Cancel out common factors. What is left over is the reduced expression. I have got to work on writing more neatly. That's not bad. All right, so let's look at an example right here. So the first thing I'm going to do is I'm going to, I feel like I skipped something there, but maybe not. So the first thing I'm going to do is I'm going to separate everything. Let me just look here. This is what I'm going to do. Step 1, I'm going to rewrite the problem, but I'm going to separate the coefficient and each variable into separate fractions. All right, so that might look like this. I would have 4/6 times x squared over x to the 4th times y to the third over y times z over z squared. Now, we might not always separate these, but I think it's a good way to start. In fact, I'm sure we will not always separate them, but I think it's a good way to start. So on top, I have 4 times x squared times y to the third times z, and here I've written it all out. And I did the same thing on the bottom. And now I want you to think about reducing these the way we just did the numerical example above it. All right, let me get a different color pen. So the 4/6, we've already done that one. It reduces to 2/3. But I want you to think about this x squared over x to the fourth. This is really x times x, and on the bottom I have x times x times x times x, right? The x squared is actually 2 x's on top, and the x to the fourth is actually 4 x's on the bottom. And these are all common factors, right? So I can cross out my common factors. I could get rid of an x, and I could get rid of another x. But then I run out on top. So what I'm actually left with is just 2 x's on the bottom. Right? Do you follow that? So then I get to the y's. Now with the y's, I have a single y on the bottom, and I have 3 of them, y to the third on top. So when I start canceling out the y's, the common factors, I can cancel out one of them, but then I run out on the bottom because I only had 1 on the bottom, and when I canceled it out, I ran out. And I've still got 2 of them on top. So that's what's left over. And then finally, the z's. So what I have with the z's is I have 1 on top, but I have 2 of them on the bottom, right? Z squared. So when I go to cancel out the z's, I can cancel out 1 of them, but then I'm still left with 1 z on the bottom. Oops, didn't color code that well. Let's make that blue. Okay. So this is what's left over when I cancel out the common factors and I multiply it back together into one fraction. On top, I have a 2 and a y squared. And on the bottom, I have a 3, an x squared, and a z. And that is my final result when I reduce this fraction. Now, typically, you guys, I'm not going to write all of these x's and y's and z's out. I'm just going to look at the top and bottom and figure it out mentally. So let's do that on the next example. All right, so I rewrite the problem. Boom. Step 2, I reduce the coefficient. Okay, we did this in chapter 1. If you're not sure how to reduce the coefficient, type it into your calculator and your calculator reduces the fraction for you. And then reduce each variable by canceling out the extras, right? So let's try this one, and let's try to do it a little more mentally and not so much writing. All right, so the first thing I'm going to do is I'm going to separate everything. The coefficients would be 21 over 3. The a's are a to the 7th over a to the 5th. The b's are b to the 3rd and a b on the bottom. And the c's have a c squared on top and no c's on the bottom. So I could leave that blank or I could put a 1 there. Either way is fine. And now let's think about how to get the answer. All right, so step 1, I have rewritten the problem. Step 2, reduce the coefficient. 21 over 3. That reduces to 7. I'll do it over here. 7 over 1. How about the A's? I have 7 A's on top, and I have 5 A's on the bottom. So when I go to cancel them out, when I'm canceling out all the common A's on the top and bottom, where are there going to be leftover A's? Well, they're going to be on top, right? Because there's more A's on top, 7 of them, than there are on the bottom. And how many are going to be left over? Well, if there's 5 A's on the bottom, then after crossing out 5 of them, I run out on the bottom. And if I cross out 5 A's on top, how many will be left? That's right, 2 of them. Now, I could do this 3, 4, 5, 6, 7, and on the bottom 1, 2, 3, 4, 5, and I could cross them out 1 and 1, and I can do another one, and I can do another one, and another one, and another one. And see, because there were 2 extra A's on top, 7 versus 5, I end up with 2 A's, and they're on top. That's the last time I'm going to write that out. The next one, I have a B to the 3rd on top and a B on the bottom. So 3 of them on top, 1 of them on the bottom. So when I go to cancel them out, where's the extra? Well, there's 2 extra on top, right? So I'm going to have a B squared on top. And the C's, they don't have any to cross out on the bottom, so the 2 on top just have to stay. And there we go. And I feel like nope, I haven't. So I end up with 7 A squared, B squared, C squared, all on top. And on the bottom, I have nothing but the coefficient left, 1. So I could just write this 7A squared, B squared, C squared, because it's all over 1. All right. I think you should try this one and then, pause the video and try it and see if you get it. But I'm going to explain it. Here we go. So first of all, I have a negative divided by a negative, and a negative divided by a negative is a positive, so I'm not going to worry about those negative signs. Okay. So notice how I set up my answer blank at the end, my fraction bar, and then I start up. Here we go. 14 over 4. That reduces to 7 over 2. The X's. Looks like I got 3 on top and 4 on the bottom, so that's 1 extra on the bottom. And the Y's. Looks like I've got 5 of them on top and 2 of them on the bottom. So when I go to cross them out, I'm going to run out after 2 Y's. And there would still be 3 left over on top. Now, if you really like to write everything out like this, and then start crossing it out. Let's see, get rid of an X, get rid of another X, get rid of another X, get rid of a Y, get rid of another Y. You can see that we're going to end up with the same answer. 3 Y's on the top, 1 X on the bottom. And of course, you have to reduce the coefficient part. I think you can do most of it mentally if you follow what I'm saying. All right. We got one more thing or so, and we are about done. First of all, a couple real easy ones, I think. But what if you only have like 1 variable, right? What you want to remember here is that if everything crosses out, if everything crosses out, there's still the coefficient. I'm going to write that over here, actually. If nothing is left on either the top or bottom, fill in the coefficient of 1. It's like, even though it's not written here, each of these really has a 1 in front of it, but typically we don't write the coefficient when it's 1. And I would just be simplifying this thing, right? I've got 35 p's on top and 23 of them on the bottom. So when I start canceling them out, I'm going to run out on the bottom because there's less of them. And how many am I still going to have on top after canceling out 23 of them? Well, that'd be how many more there are. There'd be 12 on top left over, p to the 12. And since I have crossed out everything on the bottom, it's still over 1. Although 1 on the bottom really doesn't matter. You could just leave it as p to the 12th. However, in this next example, when there's 11 3's on top and 14 3's on the bottom, now when I cancel out the common factor, I got a bunch of 3's on top, I got a bunch of 3's on the bottom, right? And I start canceling them out. I run out after 11, right? There's no more 3's left on top after 11 of them. And how many are still left on the bottom? I hope you said 3, because there is 14 of them on the bottom, which is 3 extra. Now, it seems like everything is gone on top, but remember, you can still fill in the 1. Your answer is actually 1 over 3 to the 3rd power. That 3 to the 3rd needs to be on the bottom. All right, last thing, and I'm pretty sure you'll find this easy if you have done yesterday's homework already. And that is a power of a quotient, or a power on a fraction. So when you have an exponent on a quotient, or on the parentheses of a quotient, you do just what you did when it was multiplication inside the parentheses. Now it's division inside the parentheses. You do the same thing. You apply it to each thing. So the 3 gets applied to everything. It would be 2 to the 3rd, x squared to the 3rd, y to the 3rd, over 3 to the 3rd, z to the 3rd. And then you simplify it. So what is 2 to the 3rd? It's 8. What do you do when you have an exponent raised to another exponent? You multiply them, so that would be x to the 6th. Then you've got y to the 3rd. Down here you have 3 to the 3rd. That means 3 times 3 times 3, which is 27. And you have z to the 3rd. You want to try one on your own? Give it a shot. And then see if you got it right. So I would apply this to each thing. A to the 7th to the 3rd over 5 to the 3rd. And on top, I would end up with a to the 21st, because I multiply those. And on the bottom, I guess it would be 125 if I go ahead and use the exponent. Or maybe you just leave it as 5 to the 3rd power if it's too big. Last example, and we're done. Again, try it on your own and then see if you got it right. Stop the video and try it, and then unpause it and see if you got it. So this 2 needs to be applied to everything. 2 to the 2nd, x to the 3rd to the 2nd, 3 to the 2nd, and y to the 2nd. And what does all that equal? 4, x to the 6th, 9, and y to the 2nd. And that's your answer. I hope you're good. Good luck on the homework. See you tomorrow.